The Veritasium video I posted, it's got about 500 views. It seems to be getting a lot of traffic through the browse feature. 300 or so people clicked it just from YouTube search. And then on top of that, there was 4.4k impressions on it, meaning like the thumbnail showed up 4.4 thousand times. So it must be pretty popular in the search. Other videos, I guess, are getting watched like this. So a friend sent me this link. Is Veritasium wrong about electricity in reference to the last video? So I'm going to watch this here and react to it and see what's said.
Scenario.
Imagine you have a giant circuit consisting of a battery, a switch,
Back to the
a
beginning.
light.
Last week, Veritasium released a video posing this scenario.
Imagine you have a giant circuit consisting of a battery, a switch, a light bulb, and two wires which are each 300,000 kilometers long. That is the distance light travels in 1 second. So they would reach out halfway to the moon and then come back to be connected to the light bulb, which is 1 meter away. After I close this switch, how long would it take for the bulb to light up? Is it half a second, 1 second, 2 seconds, 1/c seconds, or none of the above?
I originally guessed or just blurted out 4, which was retarded. I corrected myself. I thought perhaps C if you added it up linearly. All the half seconds, 4 times round. You get 2. And then I thought perhaps the video was made because it was none of those answers, and the video was titled Misconceptions About Electricity, so maybe there was A, B, C, D, and they were all misconceptions. So, and then I was wondering about 1/c, which is a very small time. Yeah.
If you haven't seen it, go and check it out now and then come back and watch this. I'm about to spoiler his answer for you. You've been warned. 3, 2, 1, okay.
So what is the answer to our giant circuit light bulb question? Well, after I close the switch, the light bulb will turn on almost instantaneously.
D, 1/c seconds. Quick disclaimer, TIMF, this isn't my field. That's the science version of I'm not a lawyer. My
Same.
PhD is in optical physics. I watched this video last night about 8 p.m. For the last 12 hours, it's been subtly bugging me. So I want to give my take, but ultimately, I'm very open to course corrections from someone that's had the opportunity to think about this problem for more than 12 hours. I want to talk about this in 3 parts. First, using high school science teacher logic. Second, using a thought experiment that shows that this setup breaks causality, which is a problem. And third, that I think this is using ultimately the wrong, or at least a kind of a confusing mental model to explore the problem. I want to explain what I think would actually be happening in a way that I hope you're much more familiar with. Number 1, we've all been there, we've all done it. Problem 1, the perpetual cheap shot all science teachers love to mark you down on, the units. Time here is measured in seconds. Our first options are
Meters per
0.5
second.
seconds, 1 second, 2 seconds. They all check out great. 1/c seconds makes no sense. C is the speed of light. It's a velocity.
There's no
It is measured
distance in there.
typically in meters per second. So 1/c, if you type it into Google, is 3.3 times 10 to the minus 9 seconds per meter. Seconds per meter is not a unit of time. It's a minor point. I thought, let's do a cheap shot early. The answer, if this one is correct, should have at least been 1 meter over c. Then the units would check out. Easy thing to mess up, not a big deal. Let's move on to something a little bit more concerning to me. Problem number 2, this one's maybe a little bit bigger. If this is true, in the thought experiment world that this is given, we break cause and effect. We would be able to communicate faster than the speed of light, which would be cool, but would be a bit of a problem in most universes that we're familiar with. So let's look at the scenario again, but first we need to clean it up and set some better assumptions, otherwise it becomes really hard to keep track of what is reality and where we're making a mistake. So assumption 1, as shown in the video and so baked into your kind of mental framing for this problem, we are using a car battery. These typically supply between 12, 13 volts. If we connect this to a real wire of any meaningful length to the circuit, the light bulb at the end of the day would never turn on. The resistance is just fundamentally too high in that length of wire. Let's not worry about that though. Let's imagine this in a wonderful made up physics unit.
It's also insulated, right? I don't know if the static or dynamic field that is set up surrounding a wire could connect over that distance at a small voltage of a car battery either. Makes you wonder how that light bulb lights up, right? Those cables aren't as long as the experiment proposed, so that's probably why they light up, because they're much shorter.
Universe where we can do whatever it is that we want, sidestep the problem. Assumption 2, let's say that this wire is 0 ohms, 0 resistance wire. It's a superconductor. Now the signal, even if it is just this small 12-volt car battery, can propagate all around the circuit unimpeded. It will reach the light bulb. The light bulb at some point will turn on. We know that. The ground rules for how we expect that to act: we open the circuit, the light should go off. We close the circuit, the light should go on. Assumption 3, we agreed that the light only goes on when the circuit is closed. Assumption number 4, this is the last bit, this is where the Veritasium answer comes in. We're assuming that it only takes 3 times 10 to the minus 9 seconds, really short period of time, for that light bulb to turn on. If these 4 assumptions are true, we have a real problem. If at any point our circuit breaks, say at its furthest away point, assumption 3 tells us that the light should go off. The only timings we have to go off from our set of assumptions that we have is that this should depend on the distance between the battery and the bulb. So we should notice this breakage after our 1m over c time period has elapsed. Now, if that were true, we would know about that breakage at the furthest point in our circuit faster than that information traveling at the speed of light could have been communicated to us. We would have essentially seen information communicated faster than light speed. In our universe, everything that we have ever observed says this isn't and shouldn't be the case. This is more or less the whole idea behind relativity. Observers, spatially separated, which means not in the same place, perceive time and events differently because they can only communicate at a maximum speed, and that maximum speed is the speed of light. So if this was true, some amount of information, maybe it's not that useful information, it's just whether your circuit is broken or not, can be communicated to you as the observer sitting next to the battery and the light bulb faster than you would say the speed of light would otherwise allow it to. If that were true, how would you take advantage of it? Well, maybe you would have a system where there were 2 switches, one by the battery, one at that kind of halfway to the moon furthest point, maybe it's even further away, maybe it's light years away. If someone, say at that 1 light year away mark, opened and closed their switch after we had ours already closed, our light would be turning on and off far faster than they could have ever sent some information to us, and they could be doing essentially kind of Morse code. They could be sending us messages. It would have broken the speed barrier for the universe, and we would have built faster than light communication. If all those conditions are true, so which one isn't true? Let's go through in order. Assumption 1 and assumption 2, we are using a battery to transmit energy, and we have a 0 ohm wire. Slightly fanciful, those assumptions, but they are broadly in principle totally fine. So it's either assumption 3, the circuit needs to be closed for the light to go on, which seems reasonable, or assumption 4, that it only takes 3 times 10 to the minus 9 seconds, that really short amount of time, for the light bulb to turn on. Your inclination, given that the whole premise of this video will be that the problem with it is assumption 4. Veritasium's answer is wrong, but it isn't. Or at least not entirely. Problem 3 with this whole setup is I think we're using the wrong mental model to think about this idea. This thought experiment sounds a lot like it's about circuits, but it isn't. For that light bulb to turn on, the maybe unintuitive thing here is that the circuit doesn't even need to be closed, at least not globally. In the video, Veritasium describes how moving electrons create corresponding fields and vice versa. Moving or changing fields can influence the movement of electrons. Because these wires stretch out so far, because our circuit is so big, it's difficult to even conceptualize it, at least in the initial starting conditions, as a circuit. What is easier to conceptualize this thought experiment as is a set of 2 antennae sitting parallel to each other, or at least thinking about it that way for the very short time after which the circuit is first closed. The way your car, the way your phone, or the way your radio antenna works is to hone in on fluctuations on local electric fields by tuning the internal components to resonate at the same speed that the field is moving. This allows oscillating fields to couple efficiently into the antenna, and the radio or the phone can then extract information out of those oscillations while ignoring all of the other electromagnetic fields that are waving about in the area. From this, things like frequency or amplitude modulations of the oscillating field can then be transcribed into pitch or into volume and ultimately can make some signals come out of something like a speaker. Transmitting information into the field in the first place is done in much the same way, by driving the internal circuitry of the antenna system at a frequency and amplitude to create outwardly propagating disturbances in the field. In the video, when the switch is being closed, the battery drives electrons from sitting around happily, minding their own business, to moving down the wire. That movement gives rise to a field. That field propagates outward at the speed electromagnetic waves move, which is the speed of light. When it traverses the distance between those two wires, which is 1 meter, which takes 1 meter divided by the speed at which it's moving, it starts to couple with the lamps section of the wire as if it were a second antenna. The electrons in the lamp's wire will start to move due to the fields, and your light will turn on. The minor caveat I would give to that scenario is what you actually mean when you say on, because I think that's ultimately quite a subjective measure. Will you see any light actually coming from the bulb? My guess would be probably not, at least in this setup, depending on how well the field couples to the wire, particularly if you're just using this 12-volt car battery pushing a DC voltage in one direction. Could you see some sort of voltage change though? Some sort of field detected by that wire? Absolutely, sure, I don't see why not. I think that becomes much easier for you if you increase the voltage, or if you alternate the direction that the current is running in, alternating current, or if you reduce the distance between those two wires, you'll see a larger effect. And all this feels, at least to me, true for that very initial time after you've closed that switch. Because what's happening in the meantime is that your electric field is propagating around that wire, around that circuit, until a point where it does complete the loop and interact with the light bulb. At which point, my guess would be you start to see the full power of the battery. Your circuit actually starts behaving like a circuit, and your light bulb illuminates to the full potential that it can illuminate to, which depends on the voltage and the rating of the light bulb and all those sorts of other things. At least that
Reminds me of this example, okay? See, when it comes to lightning, you can treat it like those two wires with the ends removed, like two antennae. You have the layer of the atmosphere, which contains all this charge, and you have the ground, which is another layer, and the two are like plates together, and there's this air gap between them, which has a resistive value, and there's going to be a large amount of volts and current, but the volt is what makes it jump. So you see the light go right through the resistive layer of the air and connect the two plates at the shortest distance usually, rather than taking a long gap, because the layer of the atmosphere and the layer of the ground never touch. It's two circles, right? So you can't take the wire right round because it just stays in the air. So it has to jump. So it's basically an electrical short between two plates, right? And what you see in the slowdowns of these is there's something called a leader or a feeder. And as the lightning comes from the cloud, or there is also a spark or an electrical strike coming upwards from the ground to meet it, which is interesting. It reminds me of this. So there's more than just a circuit going on there in order to make that happen. I wonder if the light bulb and the car battery need to connect in some sort of leading way, and then the current can come through, because you see the two things meet, and then the rest of the lightning comes through in a very slow motion. So it's like first a weak connection, like two strings, and then the whole thing lights up. Just reminds me of that.
That's my guess. And I would want probably some further follow-up materials to be convinced of it being other, more useful mental models. But I'm very happy to be convinced, because that's the whole point behind science. What I would want to close by saying is this.
These are the lies you were taught about electricity.
Maybe a little on the unfair side. Lying implies intent to deceive at the end of the day. Like I said, science is just a practice of coming up with what you hope to be a moderately useful model understanding the extent to which it can be used, and then as soon as it stops being useful, chucking it out or implementing some meaningful change to it so that it can then hold true in light of a new set of evidence. That process is just good science, and what you've been told at an early stage, which are simplified versions of different pieces of science, it's okay that they change and that they get refined over time. That's exactly the process, and that's you undergoing kind of a scientific thought pattern, saying, okay, but that doesn't mesh with what I now understand, so what is it that I need to change about my fundamental assumptions in order to make this universe still make sense? And if you can do
It's a lot of like mental gymnastics, but it is still a lie. You know, the half-life of facts from the show QI. All facts seem to be revised at a later date, so what was once supposed to be true, there's more depth, more resolution to the problem comes to light. And kind of like when, if you stay in physics and things like that, you've got, we thought there was only atoms, and then lo and behold there's quarks and gluons, and yeah.
that, you can do a lot of things. Thanks very much for listening. I hope you enjoyed this video. Do subscribe if you're interested. Leave me a comment about what you think. Feel free to argue with me and change my mind. That's totally fine. I'll see you next time. Thanks for watching. Goodbye.
Goodbye. Same here. If anyone wants to talk about this in the comments, I'll talk about it with you. Thanks for watching.